There's a machine so complex, so precise, that only one company on Earth can build it. It costs $400 million, weighs 180 tons, and without it, your iPhone doesn't exist. Your car doesn't drive. The internet doesn't run. This machine doesn't make chips. It makes the thing that makes chips possible, and the company that builds it has more geopolitical power than most countries. This is ASML, the most important company you've never heard of. 2020, somewhere in the Netherlands. Inside a facility the size of a football field, engineers are assembling what might be the most sophisticated machine humanity has ever created. It's called an EUV lithography system, and it's basically a $400 million flashlight that prints circuits smaller than a virus. How small? We're talking 3 nanometers. That's 1/1,000,000th of a millimeter. A human hair is 80,000 nanometers wide. These machines are etching patterns 25,000 times smaller than that. But here's the kicker. Only ASML can make them. Not Intel, not Samsung, not China, despite spending billions trying. ASML has a 100% monopoly on the most critical technology in the modern world, and most people don't even know it exists. So how did a Dutch company that started making coffee makers end up controlling the entire semiconductor industry? Let's rewind. 1984, Eindhoven, Netherlands. Two companies, Philips and ASMI, decided to spin off their lithography divisions into a joint venture. They called it ASML, Advanced Semiconductor Materials Lithography. At the time, Japan dominated chip manufacturing. Canon and Nikon were the kings of lithography equipment. ASML was the underdog, the scrappy European startup nobody took seriously. Their early machines were decent, but not revolutionary. What they lacked in technology, they made up for in obsession. While Japanese competitors built machines and moved on, ASML stayed close to their customers, iterating, listening, rebuilding. Intel loved them. Samsung loved them. Why? Because ASML didn't just sell equipment. They co-designed the future with chip makers. Tell us what you need 5 years from now, and we'll build it together. That approach turned out to be genius, because by the 2000s, the industry hit a wall. Moore's law states that the number of transistors on a chip doubles every 2 years. For decades, that held true. Companies just kept shrinking features using deep ultraviolet light at 193 nanometers. But by the early 2000s, they'd pushed 193 nanometer lithography as far as physics would allow. The industry was stuck. Engineers tried every trick: immersion lithography, multi-patterning, computational magic. But it was like trying to paint the Mona Lisa with a mop. The solution? Use a different kind of light. Extreme ultraviolet, or EUV, at just 13.5 nanometers. A wavelength so short it gets absorbed by air itself. Sounds simple. It wasn't. EUV lithography required generating plasma hotter than the surface of the sun, hitting droplets of molten tin with a laser 50,000 times per second, capturing that light with mirrors so smooth that if scaled to the size of Germany, the largest bump would be 1 millimeter, and doing all of this in a vacuum chamber because even air molecules would ruin everything. Most companies looked at that list and said, "Impossible, let's find another way." ASML said, "Hold my stroopwafel." For over 2 decades, ASML poured billions into EUV research. They partnered with Zeiss for the mirrors, Cymer for the light source, dozens of specialized suppliers across the globe. The entire project was a moonshot, except harder, because at least the moon doesn't require nanometer precision. The first EUV prototypes were disasters. They broke constantly. They were too slow. They cost a fortune. Industry analysts called it vaporware. Some investors demanded ASML abandon the project. But ASML's CEO at the time, Eric Maurice, kept pushing. This isn't a product. This is the only path forward for the entire industry. He was right. By 2017, ASML shipped its first production-ready EUV machine. It worked. Barely. But it worked. Intel ordered them. Samsung ordered them. TSMC ordered them. And suddenly, ASML wasn't just a supplier. They were the gatekeeper to the future of computing. Want to make 5-nanometer chips? You need ASML's EUV machine. Want 3 nanometers? Same machine, just better. Want 2 nanometers? 1 nanometer? Guess what? You're still calling ASML. No one else has even come close. Canon gave up. Nikon gave up. China is trying and failing. ASML has a monopoly so absolute, it makes Google look competitive. Now, here's where it gets spicy. Because ASML's machines aren't just technology, they're leverage. 2018, the US government quietly asked the Netherlands to stop ASML from selling EUV machines to China. Not because of trade, because of national security. See, advanced chips aren't just for iPhones. They're for AI, for weapon systems, for surveillance, for hypersonic missiles. Whoever controls advanced chips controls the future of warfare, and China wanted in. Badly. China offered ASML billions. They built entire fabs waiting for EUV machines. They reverse-engineered everything they could. But the Dutch government, under US pressure, blocked the sales. ASML's CEO tried to stay neutral. We're just a company. We sell to everyone. But in reality, ASML had become a pawn in the biggest tech war of the 21st century. The US didn't just want to limit China's access to EUV. In 2023, they expanded restrictions to include older DUV machines too, the ones China was using to build 7-nanometer chips domestically. Translation: America turned ASML into a geopolitical weapon. And the crazy part? It worked. China's most advanced chipmaker, SMIC, is stuck at 7 nanometers using outdated methods. Meanwhile, TSMC and Samsung are already moving to 2 nanometers thanks to ASML's next-generation high-NA EUV machines, which cost $400 million each and require their own building just to house them. So, what happens when one company controls the entire semiconductor supply chain? Well, everyone gets nervous. Intel is spending $20 billion trying to catch up to TSMC, but can't do it without ASML. Samsung is betting its future on advanced nodes, but has to wait in line for ASML's machines, like everyone else. Even TSMC, the world's most important chipmaker, is completely dependent on a Dutch company that could theoretically shut them down overnight. ASML doesn't just have customers, it has hostages, and the company knows it. Their market cap is over $300 billion. They employ 40,000 people. Their order backlog is worth tens of billions. They're not going anywhere. But critics worry, what if ASML's machines break? What if there's a supply chain disruption? What if geopolitics force them to pick sides? Because here's the uncomfortable truth. Every smartphone, every data center, every AI model, every modern weapon system depends on a single bottleneck: ASML's EUV machines. No ASML, no chips. No chips, no modern world. Today, ASML isn't just making machines. They're making the future, 1 nanometer at a time. They're developing high-NA EUV, which will enable 1 nanometer chips and beyond. They're exploring new wavelengths, new architectures, new ways to keep Moore's Law alive just a little longer. But eventually, physics will say no. You can't keep shrinking forever. At some point, quantum effects take over. Electrons start tunneling through barriers they shouldn't. The atoms themselves become the limitation. And when that day comes, the entire industry will have to pivot. Maybe to 3D chip stacking. Maybe to photonics. Maybe to something we haven't imagined yet. But until then, ASML is king. A Dutch company that started in a Philips basement now controls the entire digital world. They didn't conquer through force or ambition. They conquered through precision, patience, and a willingness to solve the impossible problem everyone else gave up on. So the next time you unlock your phone, remember, somewhere in the Netherlands, a machine the size of a bus just fired a laser at molten tin 50,000 times per second to make that screen light up. And only one company on Earth knows how to build it.